Hey there! Ever looked at a rocket or a cool modern building and wondered, how on earth do they figure out how much space is inside? I mean, these things aren't just simple boxes or balls. Well, today, we're going to pull back the curtain and show you the secret to calculating the volume of pretty much any complex shape you can imagine. So let's put on our engineer hats for a second. You see a building, a machine, or even a toy that's made of all these different parts stuck together. How do you find out the total space inside? How do you actually calculate its volume? That's the big question we're tackling right now. So, what is the secret to these complex shapes? Well, funny enough, it's that they're not really that complex at all. We call them combined solids, and once you learn the trick, you'll start seeing them absolutely everywhere. A combined solid is just a fancy name for an object made by joining a couple of basic 3D shapes that you already know. I mean, think about it. That industrial shed, it's just a cuboid with half a cylinder slapped on top. A kid's toy, that could be a cylinder in the middle with a cone on one end and a hemisphere on the other. And yep, even an ice cream cone is just a cone with a hemisphere of ice cream on top. The real skill is just learning to see those simple, familiar shapes hiding inside the bigger object.
Okay, now before we jump into any calculations, we need to get one thing straight. This is super important. Calculating volume is totally different from calculating surface area. Remember with surface area, we had to subtract the parts where the shapes touched? Well, with volume, it's way easier. You just add, or sometimes subtract, the volumes of the individual pieces. Think of it like pouring water into a bottle. The space inside doesn't disappear when you connect two containers, it just adds up.
So let's kick things off with the most common situation you'll face, building up the total volume by simply adding the parts together.
Let's take a look at this industrial shed. This is a perfect real-world example. Just by looking at it, can you spot the two simple shapes that it's made of?
Exactly. You've got a cuboid on the bottom and half a cylinder making up the roof. And the problem gives us everything we need to know, the length, breadth, and height for the cuboid, and the diameter and length for our half cylinder.
So to figure out the total amount of air that can fit inside this shed, it's as simple as this. You find the volume of the cuboid part, find the volume of the half-cylinder part, and then you just add those two numbers together. That's it. A simple addition problem.
Okay, ready to level up? Let's check out this toy. This one's a little more interesting because it's actually made of 3 different shapes. We've got a cone on the top, a cylinder for the body, and a hemisphere down at the bottom.
Now, even though there are 3 parts, the method doesn't change one bit. Step 1, you calculate the volume of the cone. Step 2, you get the volume of the cylinder. Step 3, find the volume of the hemisphere. And for the grand finale, step 4, you just add all 3 of those numbers up to get the total volume of the toy. So we've been adding volumes together. But what happens when you create a shape by taking away material from another one? Well, that's when subtraction gets its moment to shine. Just think about sharpening a pencil. We've all done it. You start with a cylindrical piece of wood, right? And the sharpener carves away some of that wood to make a cone at the tip. So how would you figure out the volume of all those little wood shavings that fell off? The logic is actually really simple. The volume of those shavings is just the volume of the original cylinder piece you started with, minus the volume of the cone that's left at the end. It's what you started with minus what you finished with. Simple subtraction. And hey, this same subtraction idea pops up in other places, like water displacement problems. Let's say you want to find out how much water is left in a glass after you drop a rock into it. You just take the starting volume of the water and subtract the volume of the rock you put in. Same concept, just a different story.
All right, let's talk about a type of problem you are almost guaranteed to see on an exam. This is where we don't just add or subtract, but we actually set 2 volumes equal to each other to find a missing piece of the puzzle. Here's a classic example. An ice cream vendor has a big tub, a cylinder full of ice cream. They use a scooper to fill up a bunch of smaller cones, each with a nice round hemisphere on top. The question might ask something like, how many cones can you fill?
The big idea here is what we call conservation of volume. Basically, the total amount of ice cream isn't changing. So the volume of that big cylindrical tub has to be equal to the total volume of all the little ice cream cones it fills. In this case, that's 10 cones. By setting these two amounts equal, we can build an equation and solve for whatever we don't know, like the height of the cone, for example.
So we've covered adding, subtracting, and equating volumes. Now let's pull all that together into a simple, clear strategy, a game plan that you can use to crush any exam question on this topic.
Here it is, your 4-step plan for success. 1. Look at the object and figure out what simple shapes are in there. 2. Write down the correct volume formula for each of those shapes.
3. Carefully plug the numbers, the dimensions, into your formulas. And 4. Do the final math, either adding or subtracting, whatever the problem asks for. Follow these 4 steps every single time, and you'll have a clear path to the right answer. And just to make sure you get every single point you deserve, let's go over the common mistakes people make. First, don't mix up your formulas, especially cone and cylinder. They look similar. Next, remember the hemisphere formula is 2/3 pi r cubed. If you have a half cylinder, don't forget to divide its volume by 2. And finally, the classic trap. Always double-check if the problem gives you the radius or the diameter.
So, after all of that, what's the big takeaway? It's this simple idea right here. When you break down complex shapes into simple solids, calculating volume becomes really, really easy. The most complicated-looking objects become totally manageable once you learn how to see the simple shapes they're built from. That's the whole game. Practice that one skill, and you've got this topic nailed.